Hello, this is Mr. Henry and welcome to lesson 0.1. We're starting a unit on rational and irrational numbers. So all the lessons are going to be basically determining if something is rational or irrational, how to convert from one type of number to another, compare them, put them in order from least to greatest, do some problem solving with them, but that's the basics, is knowing what is a rational or irrational number. Our central question is, how do I determine if a number is rational or irrational? Pretty straightforward. Did you know that all numbers in mathematics can be broken down into a few different categories? So we've got rational numbers, we have irrational numbers, integers, whole numbers, real numbers, and even these things called imaginary numbers, which we won't get to and you're not going to get to until you get to high school. But all these numbers have these separate categories. So for example, whole numbers are the numbers that you first learn when you were a little kid. You can say how many sheep there are, how many toys you have, 1, 2, 3, 4, 5. There's no fractions, there's no decimals, there's no negatives. Then you move up into integers. Integers include all of those whole numbers, but it also includes some negatives, like negative 99, negative 3, but they're still positives, positive 12, positive 8. So the integers have all of the whole numbers in it, but also has negatives. Then we move up to rational. That's one of the topics of this whole unit, is rational and irrational numbers. A rational number is any number that can be written as a fraction. So that guy can be written as a fraction. This, negative 3.5, can be written as a fraction. Same with, well, actually, even these down here. Everything inside this big circle is a rational number. I could write the number 5 as a fraction. Oopsie. 5 over 1. 17 over 1. Negative 3 over 1. They can all be turned into fractions, which makes them rational numbers. Irrational numbers, though, on the other hand, everything inside this other circle, they cannot be turned into a fraction. That is going to be the definition of an irrational number in a second on the next page, is numbers that cannot be turned into fractions. Okay, so let's see here. Rational number. Well, as I just said, a rational number is any number that can be written as a fraction. This includes integers, like, well, these guys would be like 1, 2, 3. Repeated decimals, like 2.6 repeated, 1.83 repeated. And terminating decimals, things like, well, 9.7, negative 12.6835. As long as it stops and it doesn't keep going forever, it's not a big, huge, jumbled mess of numbers, it's a rational number. And that's actually one way that I look at this. In my mind, I think of rational numbers as pretty numbers. They don't go on forever. Actually, they can, I guess, if they're repeated. But if they do go on forever, they at least have a repeating pattern. They're not just a big, jumbled mess of decimals. And that's kind of, in my mind, how I picture imaginary numbers. Imaginary numbers are any number that cannot be written as a fraction. So, for example, like the square root of 18. If we would type that into the calculator, now, my calculator looks a little bit different than yours, but the button presses will be exactly the same. So for me to do the square root of 18, I'm going to hit second, and then right above this x squared button, there's a square root symbol. That's what I want. So second, x squared, 18 equals. Now, that is 4.2426407,687, and it keeps going. We can't see the rest of it on the screen here, but that goes on forever. It never stops. And it's not a pattern. It's just kind of like a big jumbled mess of numbers from here forever. That is what every irrational number will look like. They can be positive. They can be negative. But they will always be just a big jumbled mess of numbers like it's showing here. If it is a nice repeating pattern, for example, 2 divided by 3, the fraction 2/3. If I change it to a decimal, now 0.66666, now this 7 out here That is because the calculator rounds the last digit. It's actually 0.6 repeated forever. There's more sixes, so they just keep going forever. I would call that a nice, pretty number. All right. So let's see if we can get some math in here. So for these first three examples, they want us to figure out, is the number that they're giving us a rational or irrational number? Well, first one, 0.121212 dot dot dot, means it keeps repeating that pattern forever. Well, that is a nice, pretty number. It has a repeating pattern. It's not a big jumbled mess of numbers, so this would be a rational number. Letter B. Is that a nice, pretty number? Can we turn it into a fraction? The answer to both those questions are yes, which means this is rational. I can turn this into a fraction. Boom. I can turn this into a fraction. A little preview for the future. That's 12 over 99. Don't believe me? Take 12, divide 99 equals 0.12121212, and it keeps going forever. 3/4. Is it pretty? Can we write as a fraction? Well, yeah, it's not so ugly looking. If I change it to a decimal, if I would divide that, I would get 0.75, which is pretty. And clearly it can be written as a fraction because there it is already written as a fraction. So this is a rational number. So these first three were all rational, just they look different. But every one of them can be turned into a fraction. I'm sorry, yeah, every one of them could be turned into a fraction. And the decimal version of the number is a nice, pretty decimal. Now, here's two for you to try. Here's letter D and letter E. So right now, go ahead and pause the video if you need to, copy down these two problems, and I want you to determine, are these numbers rational or irrational? When you're ready to continue, hit play, and we'll go through them together. Alright, so hopefully you're done and you did this, and hopefully you found that these are both rational numbers, both of them. This guy is rational, and this guy. This I can write as a fraction. Boom. I can write as a decimal, and it's a nice, pretty decimal. Doesn't go on forever. There it is. This one, I can write as a fraction. Now, this is technically a mixed number. I can still write this as a fraction. It would be 4/3. 4 divided by 3 is this. As a decimal, that is 1.3333333 repeated forever. That's a nice, pretty decimal. It's not a big, huge, jumbled mess of numbers. So these are both rational numbers. Okay. Letter F. The number pi. Okay. Well, let's take out Mr. Calculator again. Clear, clear. Where is my pi button? There he is. Pi equals 3.1415925. Calculator rounds 535897262 something. There's no pattern. It goes on forever. Pi is an irrational number. It is impossible to write the number pi, the actual number pi, as a fraction. Now you might remember from like long time ago in elementary school or middle school, your teacher might have used the fraction 22/7. Well, let's see. So this number was the number 3.141592653. I think the calculator shows the last digit. Oh, 54. I think it's actually 3, but the calculator puts a 4 there because it rounds. Now, if I take 22 divide 7 equals 3.142857. Like, it's not the same. They're close. And so that fraction 22/7 can be used as an approximation for pi, but it is not equal to pi. Okay? So this one is irrational. It cannot be written as a fraction. Its decimal is a big, ugly, non-terminating, means it doesn't stop, non-repeating, There's no repeating pattern. Decimal. Letter G. 4 square roots of 30. What this means we want to take 4 and times by the square root of 30. Okay, so now with our calculator, clear, we can do this one of two ways. We can just take the square root of 30 equals, get our decimal, and then times by 4. We can hit 4 times, and then to get square root, we want this, it's right above the x squared button. So we're going to hit second to get all the yellow guys. X squared 30. So this says 4 times the square root of 30. You could close your parenthesis. You don't really need to. Calculator understands. Okay, that's what it's given us. 21.9089023. Does it look like it stops? As far as it shows, no. That's as much as it shows us on the calculator. Do you see a repeating pattern? I don't. Therefore, the only thing we could determine is we'd have to say, based off the evidence we have, this is an irrational number. Okay. You could also do this for second square root without putting the multiply sign in there, because the calculator knows that that is multiplication. See, we get the same answer, and we're writing it basically like this. Make sure you're using this square root here and not the one above it. See how this other one has an x square root? If you have your calculator in front of you, you can look at it better. If I would type that in, notice how it changes. This is not the same thing. This will give us a very different answer. Okay, so just make sure you're doing square root, not this is a special root. It's like to do a fourth root or a cube root or a fifth root. Okay, so irrational, irrational. Both of these gave us big, nasty, ugly decimals that don't stop and don't repeat, don't have a pattern. Here are the last 3 for you to try, at least in this row. So you got H, I, and J. Go ahead and pause the video. Try these 3 right now. When you're ready to continue, hit play, and we'll go through them together. All right. So this guy here, negative 49 sevenths. So if you wanted to change this to a decimal, you would divide. That's what this division symbol says. So if we took 49 divided by 7 equals, oh, it's 7. This is just the number negative 7, which is rational. Because that is a nice pretty decimal. We can write it as a fraction. Easy. Letter I, 2.38594. I don't see a pattern. Dot, dot, dot means it keeps going. So the only thing I can conclude based off what they've given me here is I would have to say it's irrational. Because for it to be rational, I-O-N-A-L, for it to be rational, you either have to stop or it have to have a repeating pattern. And this does not appear to have either. Okay, square root of 19. Second square root 19 equals, all right, so we got 4.3588988944. That does not appear to stop. It fills up the whole screen as much as the calculator will show us. And I don't see a repeating pattern, so I would have to say this is irrational too. So, nice pretty number, ugly number, ugly number. All right, example 2. It asks us to evaluate the following expressions. Evaluate basically means just do the math. Simplify might be another word, but to get the answer. Evaluate the following expressions. Determine if the expressions have a rational or irrational solutions. Okay. So we want to do the math and then look at our final answer and figure out, is our answer to this problem a rational or an irrational number. Okay, that seems reasonable. So I'm going to take 1/2 times by 5 times by 9. Now, I know that 1/2 as a decimal is 0.5. That's going to make it a little bit easier for me to type it into the calculator. So I'm just going to type in 0.5. That's my 1/2 times by 5 times by 9. And I got an answer of 22.5. So now, we evaluated. Check. Is this rational or irrational? Well, I would say that's a nice pretty decimal. It stops. 22.5. Done. That means this is rational. Letter B. It says 9 pi. That is the smart notebook, how they're showing the pi symbol. It usually has a little curvy top. They make it flat. Looks like a table or something. 9 pi is what they're showing. Now, here's a mistake I see a lot. If you're trying to type this in your calculator, a lot of students will go, okay, 9 times by 3.14, because we've learned that pi is 3.14, equals, you go, oh, it's just 28.26, and that stops, so it must be a rational number, right? Wrong. When you typed in 3.14, pi is not 3.14. This is an approximation. Just like how when we use that 22/7 I talked about earlier, that's an approximation. Pi is actually a very long, non-terminating, non-repeating decimal. So if you're going to type this into your calculator, what you should do is you should actually use the pi button. So if we try this again using the pi button, 9 times, and the pi button's right here above this caret, pi equals. Now look at that. That's very different. Well, not very different. It's approximately close to this, 28.26, 28.27. They were close to the same value, but look at all these extra decimals. Doesn't stop, doesn't repeat. This, 9 pi, is an irrational number. And I can tell you pretty much anything that you're going to take times by pi, this is an irrational number. And if you times it by something, it's still going to be irrational. It's just going to be a bigger irrational number. Okay, here are two to try on your own. So go ahead and copy them down and try them. Okay, pause the video if you need to, give yourself a little bit of time to do them, and then when you're ready to continue, hit play, and we'll go through these two together. Okay, so here, I've got stuff on top, stuff on bottom. So the way we evaluate is we do the stuff on the top first to get an answer, do the stuff on the bottom second to get an answer, and then just simplify our fraction. So 6 minus 3 is 3. 8 plus 9 is 17. Simplify. Change into a decimal. Let's see what we got. 3 divided by 17 equals 0.176470588. That does not look like it stops, and I don't see repeating patterns. So if you said irrational number, you got fooled. I understand why you got fooled, because the decimal shows it looks like an irrational number. Here's where the fooling happened. Look at what you started with. You started with a fraction. This is already a fraction, which means it's a rational number. If I would pull out a website, or if I would pull out another tool, something that I could see more decimals of this 3/17, we would see that it is actually a repeating decimal. It's ugly, very ugly, and it might be 20 digits long before it starts repeating, but it does. All right. This next one, 4 times, there's a multiply there, 4 times the square root of 8 plus 5. So I'm going to do that first, then we add 5. So calculator here, 4 times the square root of 8. I'm going to hit equals here because I want to make sure the calculator doesn't like try to throw this plus 5 inside the parentheses here. So I'm going to hit equals here. Okay, so that part gave me 11.31 blah, 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 garbage. Plus 5. See how it takes your answer and adds 5 to it? So now my final answer for this letter D here is going to be 16.3137085. Okay, so let's determine, is that rational or irrational? It looks irrational. I don't see a pattern. It doesn't look like it stops. I did not have a fraction. I did not start with a fraction in here at all. So this is irrational. Got some more. They're getting a little bit trickier. We want to make sure we understand what's going on here. And so we're going to see quite a few of these. Letter E. Okay, so the square root of 100 over 9. Okay, let's see. I haven't used the fraction version of this calculator yet, so let's see. So we're going to take the square root of 100, and usually this is the fraction button. Fraction 9. Now, on your calculator, instead of showing this slash like this, it makes a little, actually, I think it goes the other way. It's like that. I don't know. It looks like a little L thing. So it's like 3, yeah, like that. 3, like 5. So, either way, your calculator, if you're using the TI-30X2S, doesn't show the fraction bar. It'll show a little L-looking thing. But let's see what this comes up with. 10 thirds. So the square root of 100 ninths is 10 thirds. Okay. And, well, I can go ahead and say that this is a rational number, because look at this. Fraction. I don't have to go any farther. I don't have to divide it. I can. I know what it is. It's going to be 3.3 repeated. But I don't have to do that. It's a fraction. It's rational. Now, another way you could have done the same problem. If you would have taken 100 divided by 9 equals decimal. Then we square root it. Second square root. Second. See, answer right here. Answer. I'm going to square root my last answer, my previous answer. Equals, look at that. Same thing. 3.333333333. That is a repeating decimal. That is rational. Now, I'm going to take a guess here. Educated guess. I know pi is irrational. And I'm going to take this irrational number times by 4 thirds times by 6 squared. I think I'm still going to get an irrational number at the end. Because in the previous examples, or one of them somewhere back here, when I took an pi times by something, I still ended up with an irrational number. I believe the same thing's going to happen again here. Now, if you're following your order of operations, the very first thing you should actually simplify, evaluate here, is this 6 squared. You do exponents before multiplies and divides. So 6 squared, another calculator feature, 6, and you see him right here, this x squared button, 6 squared is 36. That is 6 times 6. That's what 6 squared means. That's 36. Okay, so we got that's 36 times by pi times by 4 thirds. And now that there's no other, I'll call it junk, going on in the problem, I can just take this and just multiply it straight across on my calculator. I can take 4 fraction 3 times pi times 36, and hopefully this does not give me an error. Good. No error message. But I got an answer of 150.79644474. It does not look like I see a pattern. It fills up as much of the screen as it can. So I'm going to go ahead and say this is irrational. Based off this evidence and my previous idea, my hypothesis, I'm going to say this is an irrational number. I had an idea. I said I think this is going to be irrational because it's pi times by some other numbers. I tested it, and I think my hypothesis was correct. Here are two for you to try. So you've got letters G and letter H. I would recommend that you pause the video and try the two problems. When you're ready to continue, or if you're getting stuck and you'd like a little help, a little progress, you can hit play it and get yourself caught up. But try to do as much of these as you can on your own. Okay, so with the talk from the last problem, letter F, you probably flat out said G is irrational. You said, hey, look, I see pi, and pi times something is an irrational number, so I got it, it's irrational, and you moved on. But if you would actually go through and do this problem and type it all into the calculator, you're going to find this guy is actually rational. Oh, why in the heck is this going to be rational? Well, check this out. There's nothing I can do on the top to simplify this problem. That's just 6 times pi. I could multiply it out, I guess, but I don't want to yet. I'm going to leave it as 6 times pi. Down below, on the other hand, I can actually take this 4 and times by the 2. So instead of having 4 times by 2 pi, 4 times 2 is 8, I'm going to have 8 pi. Now, if I typed this into the calculator, what the calculator is going to do is the calculator is going to simplify my fraction. It's going to say, hey, look, you've got a pi up top and a pi down below. We can actually cancel those out. And I bet the calculator would simplify a little bit this 6/8. It's probably going to change it into 3/4 or 0.75. So let's see here. I'm going to put in this 6 pi fraction 8 pi equals. Now, that does not look good. I think the calculator doesn't quite understand what it is we're doing. I'm going to see if I can make it more clear. I'm going to put parentheses 6 pi fraction parenthesis 8 pi parenthesis. Okay, doesn't like that. What if we use the divide sign? There we go. So even though this is a very smart calculator, when I put in 6 pi fraction 8 pi, it didn't quite know how to evaluate that. So what I had to do is I said, I know that answer's wrong. I don't remember what it said, what it was. I don't think I can go back to it. Can I? That was an error message. What was the one above it? 7.4 blah, 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 blah. I knew that that wasn't quite right, just because I have experience of doing these problems. You may not have that experience, and so you might have got that and said, oh yeah, it's irrational. The best bet would always be, maybe try it again. Using the divide sign is a lot of times more accurate than using the fraction button. If you would take, say, 6 pi, here, let me clear all this other junk out, 6 pi equals, maybe write that down, 18.84955, 18.84955, so 3 5s, 592, over, clear, 8 pi equals 25.1327, 25.1327, 1327, 4123. 4123. And now I bet if we divide this, 18.849555, 92, divide 25.132741123 equals 0.75. So this, by the way, 3/4 is 0.75. This does simplify down to this, okay? I'm not trying to trick you. I'm trying to show you that the calculator actually didn't know what it was doing. If we just typed in 6 pi fraction 8 pi and it gave us a wrong answer, you may not have known it was wrong, okay? So, long story short, this is rational. My pi's actually cancel, and I'm left with 6/8, which then simplifies down to 3/4. Be careful how you type stuff into the calculator. Letter H. Looks like rational, maybe? You go, well, it's already kind of as a fraction, right? Well, this doesn't count as a fraction. A fraction is a whole number, like 9 or 8 or -12, an integer, on top of another integer, like 3/4. This is a good fraction. This, because of decimals, no good. You probably don't like seeing the decimals inside the fractions. Well, let's see what happens if we type this in. So I did -25.87 divided by 15.9. I don't know what this is going to give me. All right, there it is. I'm looking at it. I don't see a pattern. I don't see pretty stopping. I'm going to go ahead and say he's irrational. That's an irrational number. It did not stop. It did not have a repeating pattern. It's irrational. Alright, so letters I and J here. So this says -8 times by the square root of 25/50. Now we could do this a couple ways. We could type in our calculator -8 square root, but I'd be concerned about putting the 25/50 because I don't know how the calculator would interpret that. We could definitely put it inside parentheses, 25/50 like this. But probably the easiest way for me would be just to take the square root of that and then take my answer, whatever my answer is, and then take it times by -8. So that's what I'm going to do. So I'm going to go ahead and take second square root, so above the x squared, and I'm still going to put parentheses. Now you see how it gives us that first parenthesis? 25 fraction, you could probably also do the divide, 50 equals. So that is the square root of 25/50. Now looking at that, I would believe that's an irrational number. That is, well, let's think about this another way. This right here, 25/50, that is the square root of 1/2, or the square root of 0.5. If I did the square root of 0.5, I should get the same thing. There we go. I do not believe that to be a rational number. That is not a fraction. If there's a fraction inside, but that doesn't count if it's inside the square root. You have to take the square root of it, and then afterwards, if you can still make it a fraction, then it's rational. So all my evidence, my ugly decimals, when you take the square root of something, if you don't get a perfect answer, it's going to be irrational. This is an irrational number. Now, when I take that, no matter which method you chose, you take that and you times by -8, I believe you're still going to get an irrational number. It's just going to be -8 times bigger. And there we go. It's our irrational number. Look, no repeating decimals, no, it doesn't stop. This goes on forever. So this is irrational. Okay? Letter J. This is -37 times by 1/9 to the third power. Now, this 1/9 to the third power is a little bit tricky. If we type him in the calculator, I want to make sure I use parentheses. 1 fraction 9. And then to do the exponent here, we're going to use this caret key. So above the x squared button, there's this little up arrow. It's called a caret. If we hit that, now whatever number we click now, that becomes the exponent. If I put 3, this is this, 1/9 to the third power. Now looking at that, that looks really ugly. It doesn't look like it stops. I don't see a repeating pattern. So you might say it's irrational, but it's not. This is actually rational. What this 1/9 to the third power is doing is it's taking 1/9 times 1/9 times 1/9, which, if you would actually multiply this out, that's the number 1 over 729. And to prove it to you, what is 1 divided by 729? Well, it's the exact same thing we had when we typed in that using the exponent. Okay? So this piece right here, this is rational. It's 1 over 729. Times by negative 37. So if I'm going to take that 1 and 729 and times by negative 37, well, oh, okay, there it is. Times by negative 37. My calculator's not doing anything. All right. Times, no. Fine. My calculator's being weird on me, I guess. One divide, there we go. There we go. 729 equals, okay, so there's the decimal. Times by negative 37 equals, we got that junk. Still, it looks irrational, but it's not. If you remember about multiplying fractions, which we just did a second ago right here, you multiply across the top, you multiply across the bottom, and you simplify if you can. Well, here, if I multiply across the top, I'm going to get negative 37. If I multiply across the bottom, 1 times 729 is 729. This, as ugly as it is still a rational number. It is a fraction. There's no decimals inside that fraction, which means it is a valid fraction. It is rational. Decimal looks ugly. Sometimes it does. It is rational. So I need to say somewhere here, this is rational. All right. I would like you to pause the video, try these two. I understand that letter L looks pretty hard. It is a challenge question to test your abilities to see if you can do. My recommendation is you follow the order of operations, and just as a hint, the very first thing you're going to do is the stuff inside of the square root there. Okay, so try these two problems, pause the video, do them. When you're ready to continue, or if you need a little guidance, hit play, and then we'll go through them together. Okay, so here we go. This, I'm not going to mess with him yet. He's just 1/3. Now this, on the other hand, square root of 25, I'd like to know what that is. Now, maybe some of you do. Square root of 25 is 5. Because, I know that because 5 times 5 is 25, and the square root kind of is the opposite of this, of taking a number times by itself. So this fraction really just turns out to be 5 over 8. So I'm taking 1/3 plus 5/8, and I don't know what that is off the top of my head, but I can figure it out. 1/3 plus 5 fraction 8 equals 23 24ths. Now, if you went a step farther and you divided this, 23 divided by 24 equals, looks like we end with a repeating decimal. It's rational. Also, if you stopped right here and said, you know what, that's a nice pretty fraction, you're absolutely right. It is a nice pretty fraction, and that is rational as well. All right, tricky letter L. Let's see what we got here. Erase this and this, and here we go. Alright, so we are going to do the math inside the square root first. So I'm just actually going to start writing down the rest of the stuff. That was ugly. Alright, negative 8 plus the square root of 8 plus, well, 4 times 2 is 8. Even inside the square root here, you do the order of operations. You do the multiply first, add and subtract second. So 4 times 2 is 8. And actually, we could probably save ourselves some time and a step or two. What's 8 plus 8? 16. Alright, so we're just going to throw in a 16 right there. This junk right here equates down to 16. Down below, the bottom, 2 times 6. Well, that's 12. So let's simplify it and put 12. Our problem looks a lot easier. There's only 3 numbers versus the top one. There's like 6 different numbers flying around. Okay. Well, I'd like to be able to take negative 8 plus the square root of 16. I want to simplify this top. So we should probably figure out what the square root of 16 is. If you don't already, you type in the calculator. Square root 16 equals 4. See? Because 4 times 4 is 16. So this is equal to 4. I bring everything else down. Simplify. We're doing fraction stuff. Negative 8 plus 4 equals negative 4. That's integer math. Negative 8 plus 4 is negative 4. There are more negatives than positives. So your final answer should be negative over 12. And the last thing we need to do is simplify. You always simplify your answers when you are done with fractions. And negative 4/12, if you don't know, you can kind of type it in and the calculator will simplify for you. Negative 4 fraction 1/12 equals negative 1/3. Top and bottom here can both be divided by 4. You do get negative 1/3. And there we have it. This is what this stuff all simplified down to, is just negative 1/3. So we evaluated. Now we need to determine, is our answer rational or irrational? The answer is rational. That is a nice pretty fraction. There's no decimals in there. If we would divide it, we would get a nice repeating decimal. Negative 1 divide 3 equals repeating decimal. This is a rational number. By all definitions, it's a nice pretty number. It's a repeating decimal. It can be written as a fraction. It's rational. Alright, so we got a couple little problem solvings. You got what? I think one multiple choice problem, and we're done. Sam has the number 13/19, which when written as a decimal is that. Okay, let's just double check our little calculator here. Clear, clear. 13 divide 19. I'm not using the fraction button because if you did 13 fraction 19 equals, it's going to say, hey, that's 13/19. Yeah, thanks. To change a fraction to a decimal, you divide. 13 divide 19 equals 0.682105. And you see there's even a little rounding here. That has a 3. This has 2 6. Okay, it's correct. Sam does not know if this number is rational or irrational. How would you explain to Sam if his number is rational or irrational? Okay, well, I guess the first thing you have to decide is it rational or irrational? This should be, is a rational number. And if you look at it and then go, that decimal does not look like it stops and it does not look like it repeats. It looks ugly. You're right. But it came from a fraction. In some previous problems, we had 23/24. It looked ugly. It's rational. Here we have 13/19. It looks ugly, but it's rational. Because it's coming from a fraction, it is a rational number. And that's exactly what I'd say. How would you explain to Sam and say, this comes from it starts as a fraction. Starts as a fraction. Therefore, it is a rational number. There. My typing is probably prettier than my handwriting. So there. It is rational, and that's why. Because it started as a fraction. That means it's rational. The definition of rational is it can be written as a fraction. Well, there it is as a fraction. Letter B. A soup can is made from a rectangular piece of aluminum that is wrapped into a cylinder. That is true, by the way. If the soup can has a diameter of 3.5 inches. All right, I don't have a picture here, so maybe you need an example of what that is. So, soup can. Soup can. All right, there's my soup can. If you would unroll this thing, in case you're curious, if you ever take a soup can and unroll it, it would look kind of like that. Top of the can is a circle, bottom of the can is a circle, and this middle piece is just one rectangle. It's kind of rolled into a circle. Okay? Now, it says the soup can has a diameter of 3.5 inches. A diameter is from one edge of the circle the whole way across to the other edge. Determine if the circumference of the soup can would be rational or irrational. So is the circumference rational or irrational? Use the formula for the circumference of a circle, C equals pi d, where C is the circumference and d is the diameter. Okay, they give us a formula, we write down the formula. There's a reason they gave it to us, is because we have to use it. Now, I'm going to plug in what I know. They want us to find the circumference. I don't know that. They told me the diameter is 3.5. I know pi is pi, or 3.14. Now, if you type in 3.14 times by 3.5 equals, you get 10.99. It looks like a rational number, but it's not. Because again, 3.14 is not pi. It is an approximation. It's something we do to make our lives easy so we don't get a ton of unneeded decimals. If you hit the pi button times by 3.5, we are going to get a big, ugly, ugly decimal. This does not stop and does not repeat. That means the circumference is irrational. Here's one for you to try. You do not have to write out the whole problem unless you choose to do so, but you do have to do the problem in the space provided on your page. So it says here, a square has an area of 45 feet squared. The length of each side of the square would be square root of 45. What is the length of each side of the is the length of each side of the square rational or irrational? So I want you to pause the video, try the problem, reread it again if you need to. When you're ready to continue, or if you need some help, hit play and we'll go through it together. Alright, so picture time. I love pictures. Here is my square. Ain't he a beaut? It says this square has an area of 45 feet squared. Okay? And it says the length of each side of the square would be the square root of 45. So every side is that big. And the question is asking us, is the length of each side, is this number here, rational or irrational? Well, let's find out. If I take this square root of 45 and I throw them into the calculator, square root, make sure you're using the regular square root, not the one that has the x in front, square root of 45 equals 6.70820393, blah, 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 blah. Doesn't stop, doesn't repeat. It is an irrational number. Letter D. Another one for you to try. It says in a fish tank there are 13 goldfish and 20 fish altogether. Is the ratio of goldfish to all fish a rational or irrational number? And how can you tell? Go ahead and pause the video, try the problem out. When you're ready to continue, hit play, and we'll go through it together. Alright, so you're looking for the ratio of goldfish to all fish, right? Find the ratio of goldfish to all fish. Okay, how many goldfish? 13. How many all fish? 20 fish altogether. 20. Is that rational or irrational? Well, it starts as a fraction, so there's your first hint. It's rational. Now, the trick here is, the same trick I've tried to trick you with a bunch of times now, if you divide this beast to change it into a decimal, it's nasty and ugly. Actually, I lied. It's not. That's a nice, simple decimal. I figured because there's a 13, it's going to turn out ugly, but it's not so bad. So this is very rational. It's a pretty decimal. It is a pretty fraction. It is rational. Now, I'm not going to write on here my explanation of how it does say, how can you tell? Explain that. Explain that it starts as a fraction. Or the ratio is a fraction. Explain that if you change the ratio into a decimal, it is a terminating decimal. Those are all reasons on why it's a rational number. I believe this is the last problem. Multiple choice. Which of the following lists are made of entirely rational numbers? So we're looking for only rational numbers. We want to figure out, and probably the best way to do this would be to use elimination. Find the ones that have irrational numbers and cross them off. Things like this struck my eye when I took a glance over all these problems. 5 times pi. I know that this guy's going to give me an irrational number. So this list is not entirely rational. So it's not him. Glancing over the other problems, do you see anything else that strikes you as very irrational? How about letter B? Him. Doesn't stop. Doesn't repeat. That's irrational. That guy's irrational, so it's not this list. Now, maybe you don't know for the other two, and maybe you didn't get that for letter B. If you start going through here and go, okay, 3. That's a nice, pretty number. 9.6 repeated. That's not too bad. Square root of 40. I'm not so sure about him. Okay, so we throw him in the calculator. Second square root of the x squared, 40 equals. It's not looking so good. That does not repeat, and that does not follow a pattern. He is irrational. Now, we think the answer is letter D, because we crossed off other answers, but maybe we made a mistake somewhere. Don't just immediately go, oh, yep, it's letter D, I'm done. Check it. Make sure they're all rational. Take those extra couple seconds just to make sure you didn't make a bonehead move somewhere. So this guy, let's see. Well, he's already a fraction. There's no decimals. There's no weirdness going on. He's a fraction, so he's good. This is a repeating decimal. That's okay. That's a nice, pretty number. Good. This one, I'm not so sure about yet. This is a fraction. 15/19. It's an ugly fraction. If I take 15 divided by 19, it's not going to be so pretty. But I can tell because it starts as a nice, pretty fraction. No decimals. So now, 4 times the square root of 36. 4 times the square root of 36 equals 24. So this guy's just the number 24 written with square roots and stuff. So that is rational as well. So now we've verified it is letter D. That's the rational number because none of the other ones had only rational numbers. Pi makes this guy irrational. This guy we square rooted. This one, does not repeat, and does not terminate. Summary. So I'm not going to do the summary question here. You guys do that on Schoology if you need to. I'll show the question. It says, what is the difference between a rational number and an irrational number? So give, in your own words, what is the definition or the difference between the two? Okay. This has been lesson 0.1. Thank you for watching.